Okay, this is W6WUH. We're going to take a minute to revisit the Heathkit HG10B VFO because I think it's really a very, very nice VFO for a lot of reasons. Among all of the inexpensive or cheap ham band external VFOs, this one is my favorite, and I'll tell you why. This one was one that I bought as a flea market kit that had been butchered up by somebody, which is pretty unusual with Heathkits. But this one had to be stripped down to the major components and rewired. Well, let's just take a look at what it is here. We'll just work our way through the basic layout of the thing. Looking at it upside down. This is the 80-meter coil. This VFO covers 80 through 2 meters. This is the 80-meter coil. It only works on 80 meters, and the associated trimmer capacitor. So when you're aligning this thing, you set the coil for 3.5 megacycles. Then you check it at 4 and jockey the two back and forth until you get good calibration between 3.5 and 4. The next coil up is this one, and this is really the heart of the beast. This one works on, this is 40 meters, but when you're operating 40, 20, 15, or 10, you're really using the 40-meter section of this VFO. So again, set this for the bottom of the band, check it at the top, juggle back and forth between the two until you get good calibration. The next one up is pretty interesting. This coil and that tuning capacitor are for 6 meters, so it's 8 to 8 point, let's check my notes here so I don't tell you wrong, 8 to 8.2 megacycles, so you're juggling the trimmer and the coil back and forth to get it to track between 50 and 54 megacycles. Then when you switch to 2 meters, it's using the same coil but 2 different trimmers, and you set one of the trimmers for 144 megacycles, and the other trimmer, C4, you set at 147.6. So this is basically 8 to 8.2 megacycles. I'm sorry, 6 meters was 8 to 8.4, or 8.4 to 9. Let's do this over. 6 meters. You're setting this to 8.4 to 9 megacycles, so it tracks 50 to 54 megacycles. And then when you go to 2 meters, you've got a different set of trimmers, C3 and C4, and you're setting it for 8 to 8.2 megacycles, which corresponds to 144 to 147.6. So anyway, you've got temperature compensating capacitors in there, you got trimmers, you got coils, all pretty basic. The thing that sets this thing apart from the other cheap VFOs or standalone ham band VFOs is this split gear anti-backlash setup here. This is split gears with springs so that there's no backlash in here at all. Pretty good gear ratio, and a differential capacitor. This is C1 and C2 in the schematic. A differential capacitor. So really one section of that is working on 80 meters C1, and then the other section comes into play for 40 meters. And that's a part of the band switch selection. The other thing that's so nice about this VFO is the gear train. This has a drum dial which rolls over. Maybe I'll stop this for a minute. Well, let's look at the mechanism first. It's got a drum dial which rolls over, so you're only looking at the band that you're of interest at any one time. And it's got the very good wide dial calibrations, and then this very nice gear train in here, which gives you the fine frequency adjustment with no backlash. Now, if you know about the earlier Heathkit VFO, the VF1, it had a straight connection with a vernier to the tuning capacitor, and it was very, very fiddly. If you were trying to use this for sideband, VF1 for sideband, it was nearly impossible to get zero beat because there wasn't enough gear reduction. But this has a lot of gear reduction and lets you tune your frequency very finely. I'm going to stop this for a second and flip it over, and we'll just look at the front of it for a minute. Oh, the other thing that's of importance in this thing that we'll talk about, and we should talk about, is if you get this thing, don't just hook it up to a power supply and let fly with it, because it is fairly particular about the B+ voltage as you feed it. There's a chart in the manual. Let's look at it here. I think it's worth looking at. You absolutely have to get this manual and get this chart. And let's just go ahead and put it on the video here so you can see it. It's important that you choose your dropping resistor to match the voltage, supply voltage that you have. Just giving this example here, they've shown 350 volts. Say you're robbing B+ out of a small transmitter, 350 volts. You follow it over until it intersects this diagonal line. Go down on the chart, and it shows that you want a 10-watt, 10K resistor. In my case, I have made a little homebrew supply that only supplies about 160 volts. So maybe you can see in here that I've drawn in with a pencil and come down here, and I need 2250 ohms at 2 watts. So you want to feed this thing the voltage that it wants. It's got a VR tube inside, and the voltage regulator tube will put 108 volts on the plate of the oscillator tube and 90 volts on the screen. But if you got to check in here and see what the internal dropping resistor is. In my case, I have no dropping resistor at all because I know I'm going to feed this thing, or I thought I was feeding with an external supply and setting it to 108 volts. So now I'm going to put my 2500 ohm resistor in here and use my homebrew supply, which feeds at 160 volts, and it's dropped to about 110, and then the VR tube takes care of it. Okay, looking at the dial on this thing, I haven't got this drum adjusted exactly right because I really never finished working on this thing. But here we'll just show you that this is a drum dial that rolls over, and it should be positioned just about like that. That's a little bit off. But you can see, I've got a better pair of glasses on here so I can see. I can't see crap about my glasses. That this is giving you, what is this? 5 kc calibration. There's 7.3, 73, 50, 74. So 70, 73, 5, 10. Is that right? 10, 15, 20, 25, 30, 40, 50. So it's 10 kc calibration, and there's, I don't know, a quarter of a turn, 10 kc. Let's see what it takes here. there's a half a turn about, and there's a full turn. So one turn was 40 kcs on 40 meters, and on 80 meters it's just about the same, about 40 or 50 kc for one turn. So if you need a 2 kc adjustment, it's not too hard to get it. See what it looks like up on 15 meters. That's 20 kcs, I think. Yeah, 45, 20, 40, 60, 80. Yeah, that's 20 kc. So by the time you get up to 20 meters, it's probably going to get a little fiddly on sideband, and I don't know, 10 meters. That's 15 meters. The knob's not in the right spot. There's 10 meters. So that's 100 kc right there. This would get pretty fiddly for sideband on 10 meters. I think it's good enough for AM, and you'll zero beat easily enough. But there it is. By the time you get to 2 meters, I don't know. Good enough for AM, but I think for sideband it'd be pretty goofy. But for the low bands, I think this thing is just swell. And of course that's what I'm using it for, my vintage sideband and AM transmitters. So there it is, very simple controls, nothing to it. You can set it up for grid block keying, or just plain old ground to transmit cathode keying, and plug your key into it, and that's all there is. Let's look at the adjustments on the top. So there it is with the cover off, but sitting on the bottom, and it's not very hard to calibrate this thing. Before you start doing that, you really want to test this 6CH8 and make sure that it's a good, nice new tube. You don't want to calibrate it with an old tube, then put a new tube in it. You'll have to recalibrate it. So anyway, I've written on here with a felt tip pen to make it so I don't have to refer to the manual when I do it. This is a good technique to use, and a little bit of rubbing alcohol will wipe that right off. You'll never know it was there. But anyway, use the manual to tell you how to do it. Basically, all you need is a receiver to calibrate the thing. If you got any kind of a digital receiver, or even a regular receiver and a crystal calibrator, to get the calibration right on a receiver, you can do this. Basically, on 80 meters, you're going to set the coil at 3.5. You're going to go up and check the dial calibration up at the high end of the band at 4 megacycles, and if they say that if it's off, go back to 3.5 and move the dial in the direction that the thing was off of, maybe about 10 kcs. Zero it with the coil again, go back up to 4, set it with a trimmer, and you're just juggling the two until you get good calibration across the band. The end points should be set very accurately so that you don't operate out of band, and then the rest will fall in line if you do that. Same deal on 40 meters, and of course 40 meters when you're working on multiples of that, 20 meters, 15 or 10, you're using harmonics, so the more accurate you are on 40, the more accurate you're going to be on those other bands. 6 meters, you're looking at between 8.4 and 9 megacycles. The same deal. Get the basic low end of the band set with the coil. Jiggle the trimmer in the coil until you get calibration across the band spread. 2 meters, you're going between 8 and 8.2 megacycles. and you're calibrating the thing at 144 and 147.6. So that's the deal. Not much more to say about this thing, except that compared to earlier VFOs like the VF1 or the Johnson 122 or the Globe 755 or 755A, this has a much finer, more precise dial tuning mechanism, the anti-backlash drive, good band spread, good repeatability, just much superior mechanically to those other VFOs. They were stable enough once they warmed up on 80 meters. This thing, when I turn it on, it's right on the frequency I left it, and an hour later it hasn't changed any. How it behaves on the higher bands, I don't know yet, but anyway, just mechanically and electrically, this thing is far superior to the earlier Heathkit, ICO, Lafayette, WRL, or Johnson VFO. So I recommend this one very much if you have a vintage AM gear, and for vintage sideband gear that has no VFO, this is not a bad choice. Well, this is not a very ideal setup in terms of the video, but what we're going to do here is set the calibration on this thing for 80 and 40 meters at least. I don't know if you can see the receiver up here or not. None of this is ideal because I'm trying to get the receiver and the VFO in the frame at once, and it's very hard to do. Anyway, this thing has only been on for about 10 minutes. It's still a little cold. It may drift a little, but I turned it on. I ran it down to the bottom of the 80 meter band to 3.5, where you're supposed to set it, and I found that it was 20 kc off. So here it says I think it's moved that much again. My receiver says 3.520, 3520. So I'm going to get in here, and I'm going to adjust. I got to get more light. I can't see. It may make it impossible for you to see the receiver, but anyway, back here is got a L3. So what the book tells you to do is set your receiver to 3.5 even. So we'll do that. Now this is going to be off a KC or two because I got it in the lower sideband mode, but if I don't do that, I got no zero beat. So there's 3.50. Dial is set to 3.50. And there we are. So very close. So now what we do is run the VFO up to the top end of the dial, which is 4 megacycles on this band, 4 megahertz if you prefer. And we set the receiver to 4 megahertz. And now we're going to tune around up there and see where it really is. $39.96.3, so it's only off 3 or 4 kc, which is quite good. So we're going to set it to 0 to 4 megacycles on the bunny. And we're going to adjust the 80 meter trimmer, which is C7. So we'll give a listen here. We'll tweak that little trimmer a little bit. So there we are. Now we're going to go back down to the bottom end of the band again, 3.5, and we're going to check it again. Now if you ever set the calibration and the tracking on a receiver, it's just exactly the same thing as we're doing here. There's no difference at all. So we're going to set this to 3.5. Going to run the receiver back down to 3.5. Spend more time tuning the receiver than anything else. And give a listen. Well, we'll tune the receiver and see where we are. Not finding it at all. It's not good. Well, I don't know what's... Oh, got to turn the VFO on. That'll help a lot. So there we are. It's off 20 kc again like it was before. So now you are in the realm of where you're going to split the difference. So what it tells you to do is run the VFO about up a frequency about 10 kc. Set the receiver back to 3.5. Twiddle the trimmer and see if you can get it to come back in. So now, oops, I did it wrong. I forgot to reset the VFO to 3.5. So now we'll do that anyway. We'll go back and set the VFO. Oh, wait a minute. Alright, let's take the VFO back to 3.5 and adjust the coil again. Okay. Now we're going to go back up to 4 megacycles. And this is repetitive as hell. But you're just splitting the difference with this thing until it's pretty good. Okay, Larry, W6WUH. I have been working on the 80 meter tracking and calibration of this thing for nearly an hour, believe it or not. Of course, they didn't really warm the thing up very well, but it doesn't make an awful lot of difference with this thing. And here's what we got. So right now the receiver is set to 2550, and that's what the dial says. So we'll run it up to 3600, set the dial, and we'll run the receiver up to 3.6, and there it is. So we'll run it up to 3650, 3.65 megacycles, run the receiver up there, and basically there it is. Run it up to 3.7. And within a couple of kcs of the dial calibration, there it is. Run it up to 3750. There it is within a couple of kcs. Dial might be reading 2 kc high right now. 3800. Now this is where I expect it to be pretty accurate. And it's within, I don't know, it's 1 kc high or something. The pointer is 1 or 2 kc wide. So what can you do? 3850. There it is. Now we'll go to one of my AM frequency, 3870 for the West Coast AM, and we'll see what this receiver says. Dial's still about yeah, it's about on. There's a little tilt to the pointer, so it's a little ambiguous. We'll go to 3895. I'm going to try to dial up my vintage sideband frequency. We'll tune in the receiver and we'll see how I did. Well, you can hear how high I am. Actually a little low. So that's off by a kc or two, but that's about as much dial accuracy as you can expect from this thing. We'll go up to the band edge. I'm going to set this to 4 megacycles, and we'll see what we got. There it is. Right on the money. So I think that's about what you can expect trying to calibrate this. If you have infinite patience, and maybe if you can work out any slop in the slide rule needle, you may be able to get it better than that. But I think compared to what you could do with one of the older standalone VFO, this is quite good. So I'm going to go up and work on the 40 meter part of it, and we'll see what we get there.